I promised earlier in the course that we would come back to the idea of mutable versus immutable object. An object is just an element of data that we're storing somewhere. It could be a simple element like an integer or something much more complicated. A mutable object can be modified after it's created. We've seen this in the case of a dictionary, where we can change the value of a particular key after the dictionary is created, or even add another key value pair. An immutable object cannot be modified. We saw that in the example of a string, where we tried to change one of the characters of the string, and it didn't work. It gave us an error. It said assignment was not possible. In fact, everything we've seen so far, other than the dictionary, is an immutable object. So integers and floats are all immutable objects. It's really important to understand when you are creating a new object and assigning it to a variable versus when you are changing an existing object. Let's do some quick coding to demonstrate that. I'm just going to code all this up at the module level. So we said that the integer is immutable. Let's see what that means. If we create an integer object 6 and then bind it to the name myInt, and then create an integer object 7 and bind it to the same name, we haven't changed the value of this object. We've actually created a brand new object and we've reassigned the name myInt to the brand new object. We can prove that by printing out the ID of the object that myInt refers to. We use the ID function, and we'll do that twice. You can think of the ID as roughly the place in memory where the object is located. It's not exactly true, but close enough. If we run this, we see that that ID actually changes, meaning that the object that myInt originally pointed to is not the same object after the reassignment. Let's contrast that with a dictionary. We'll create a dictionary, and remember that we do that using curly braces, and we'll print out the ID of that dictionary. Then let's change the value associated with the key 1. And we'll run this. And we'll see that while myInt changed object IDs, my dictionary did not. So we can change something about the dictionary object without changing the dictionary object itself. However, if you do another assignment that looks like the original assignment, and run this program again, we find that the ID of the dictionary then changes. In each of these cases, we were creating a new dictionary object and then binding the name myDictionary to that object, here and here. In the second case, we were reaching into an object that we already created by using this index, and we modified the value associated with that key. Note that we can create a new name without creating a new object. We can take the name yourDictionary and set it to the same object as myDictionary without actually creating a new object. Let's clean up everything else here. The only place a new object was created was in the first line. If we do an assignment operator from one name to another, we're just saying that we want both of those names to refer to the same object, so that when we print the ID of myDictionary and yourDictionary, we actually get the same object. This is important, and it comes under the umbrella of mutability, because if we now reach into yourDictionary and make a change, it'll affect myDictionary. Let's change the key 1 back to the value it should contain. Notice that we originally assigned the value WON to the number 1 in myDictionary. Then we created a name yourDictionary, and we assigned myDictionary to yourDictionary. It seems like that would create a copy of myDictionary that we could play with, but really both of those names refer to the same object. We can see that when we print out the IDs, and then when we go in and change the value associated with the key number 1 in yourDictionary, we see that the effect is passed on to myDictionary, because really we're reaching into the same object. Later in the course, we'll learn how to make a true copy of an object rather than just copying the reference to that object.